Good afternoon, chemists. Welcome to week 14. It has been such a fast semester. I cannot even believe this. When I was doing the announcement for the week, I was really thinking back about my week and weekend, and I just have been feeling a lot of pressure, a lot of stress with personal life and then with work and trying to balance everything. And I was really going to be doing some work in this certain section of the weekend, and my little son was not having it really. So I sat down with him and my older daughter, and the movie Cars was on. And so we were enjoying the movie Cars. And the next day I knew we all fell asleep together on the couch. And I think back to, like, there were no phones, there were no iPads. It was just really us, the movie, and having some fun and together. And it was really like a nice unplanned surprise time. I was like really thankful for it, even though I had planned on doing work and I was a little bit stressing out. All in all, it was like just kind of what I needed. And so I was wondering if that has been happening to you guys, where you're feeling a little bit stressed, a little bit anxious, a little bit like, oh my gosh, I got to get this done. And something happens that just really takes you back and makes you just take a step back and take a break from all of that. If you're willing to share any of that, please do so in the chat. I cannot see if you guys are typing, so I apologize if I just start talking and you are really typing. Well, that is pretty awesome. I'm glad that you are feeling like your schedule that you've got going on is really working for you. Anyone else care to share? Yeah, I just this time of year just seemed to be like kind of explode on what all has to get done, and it definitely has left me a little bit on the stressed side, but that's okay. All right, so this week we have ionic and covalent compounds. And for this, we're really talking about how we're naming and writing these types of formulas. We have two different folders. I'm going to go through those two different folders, and then we will do a presentation on ionic and covalent. So let's get started here. All right, so there are two folders that we have. Our main goals is to be able to write a proper ionic formula, to be able to write a proper molecular or covalent formula, and be able to name the compound that is given to us. It really is a skill in chemistry that will not ever, ever, ever go away, and it will continually build upon itself. So Mr. Wozniak and I decided that we would put these each in a separate folder, since they are two different types of compounds and they do require slightly different skills to write and name each of them. So first of all, in here you have ionic. We put a list of polyatomic ions here for you. And it is really in your best interest to print this off. Keep in mind, like, you might be saying, like, where the heck is the link? But this is the link to the list right there. You would just click on it. We're really, 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 really recommending that you either are able to print this off and or handwrite this somewhere, because you will be referring to this quite often, especially when you don't really know what polyatomic ions are right off the bat is when you are doing some chemistry reading or writing of some chemical sentences. You're really going to need this list. And so I just really highly recommend that you do this. Okay, then we have in here for you, you could print these off. Again, these are the fill in the blank sheets. We have an ionic compound Google Slides that you would utilize to help you do this. And then we have some ionic compound writing practicing. So all of these things are here for you to go through at your own pace. Again, this is not something that you can skip these things and still be able to know what you're doing. It's best if you just take the time to do them, and then you will, it will make more sense to you. Being frustrated or a little bit not understanding right away is okay. Chemistry, this is going to be new to you. This is probably something that you have not yet seen in previous science classes. So give yourself a little bit of time. We also did put a video in here for you too. Sometimes people need to hear it and see it being done at the same time. So that is there for you. We also then have a folder right here that has a formative for you to do some practice of writing and writing formula exercise, meaning you're writing them and naming them. And then we have an assessment for you guys to take on these. Okay, so that is ionic compounds. And when we go back here, we then have covalent compounds. Again, we have a presentation. We also have a note sheet. You can see, like, I chose to just handwrite my notes in my notebook, but you can also grab the template right off of here. And then this is done in a PowerPoint. So the PowerPoint is attached right up here. This is something that I haven't yet converted into a Google slide. So it's sitting up here for you to click on if you don't want to watch it through the video. And then we have a covalent compound, practicing on covalent compounds for you to do, and taking pictures showing that you did do the practice of the covalent compounds. So that is what we've got on tap for this week here in chemistry. These two folders, there's 2 formatives and 1 summative at the end of the week. You could attach, yes, the PDF. Yep. Okay, so at this time, what I'm going to ask that you guys do is, if you are wanting to stay for the rest of the e-session, I would need for you guys to grab your notebooks. I would need you guys to have your periodic tables with you. And if you, by chance, printed off the polyatomic ion sheet, that would be spectacular to have as well. Otherwise, I'm going to refer back to it as often as I can in the presentation. I need you, I'll just put, I'm going to put on my timer about a minute, and let's just see. Let's go 1 minute and 9 seconds since today is the 9th. And then we will begin our look at writing and naming compounds or formulas. Give me a thumbs up when you are ready to go. You have 1 minute, 9 seconds. Notebook, periodic table, something to write with. And if you have polyatomic ion sheet, that would be amazing. All right. So let me share my screen here with you. Okay, so it looks like just a couple of you are ready to go. And I guess we can get started. Hopefully more of you are ready to go than just the 4 that put thumbs up. Samantha, no, you do not use prefixes for ionic compound, or you do not use the prefixes for ionic compounds. That is correct. All right, so writing and naming compounds. So we're going to start out with ionic compounds here. Okay, and we're going to start out by naming them. And like I said, you will need your periodic table. It's good to reference them, or you're going to need to reference it because obviously you might need to look up names. So with an ionic compound, I just want to reiterate to you guys, let me get my little pointer here. I want to reiterate to you guys that this is a compound that has a metal and a non-metal. And so for you to really know and understand whether you have a metal and a non-metal, this is again where you need your periodic table. We way back towards the middle, if not a little bit before the middle of the semester, so maybe around week 5, 6, 7, somewhere in there, I think, we went through and started labeling our periodic table. And on the left-hand side is all of the metals. On the right-hand side are the non-metals. And we have this like thick black step line that we call like the metalloid line. And so really that's kind of your judge that if it is to the left of that line, you have a metal. And if it is to the right of that line, you generally have a non-metal. And so when you are looking at a compound, one of the first things you need to do is identify whether it is a covalent or an ionic compound. Before I move on, is there any questions or clarifying questions about an ionic compound being one metal together, one non-metal? Okay, so when you are writing or you see an ionic compound, generally the metal will be first and the non-metal will be second. So I'm using my example right here. So sodium is a metal, chlorine is a non-metal. And when we name ionic compounds, it's rather simple. You are going to name the metal first. So you see that I have Na here and I have sodium written down because that's all you need to do is just write sodium. And then you are going to write the name of the non-metal down. But you are going to take off the ending and add IDE. So instead of me writing chlorine here, I wrote chloride, so IDE. And let's see, do I have options for a pen? No, I don't. Okay, so you can see that I have IDE. Instead of writing chlorine, I wrote chloride. And so we will call this compound sodium chloride. When you look at this right here, what questions do you have? Like, what doesn't make sense to you as to the two rules of naming the metal and then naming the non-metal and adding IDE? Oh, didn't mean to do that. All right, I'm not seeing anyone. I can't see if anyone's typing, but I don't see any questions coming up. So what I would like for you guys to do is to start with MGO and LIBR. I am going to put I'm going to put 45 seconds on the clock, and I'd like for you guys to practice naming these two compounds, MGO and LIBR. Please don't put the answers in the box yet. I'd like for everyone to try. All right, time is up. I'm just doing this because I can't type when I'm in that mode, and I'm dual screening it right now. So we had Eleanor nicely tell us that this was magnesium oxide. So instead of writing oxygen, we write oxide. We take off those, the ending of it, and write IDE. No worries. And then LIBR, does anyone want to put what they think that LIBR is? Ooh, not burr. Lithium bromide, very good. All right, now I can go into insert. Okay, so that should be better for you guys to see now. So we have, oh, well, that didn't work out well, did it? Oh, because it's all the way down here. It's just, there we go. All right, so we have magnesium oxide and lithium bromide. So if you got these right, give yourself a clap, or we can snap it for you. And if you did not, this would be at the time to ask a question about what you thought you did right, but maybe you did not, when it comes to naming these compounds. So at this time, are there any clarifying questions about naming them once you had the opportunity to try them out on your own? Yep, that's coming up next. Just hold on. Okay, so it looks like we're doing okay with the naming portion of it. It's really, once you've identified the type of compound you have, it is fairly easy to name them. There's really nothing much to it. Now we're going to talk about putting an ionic compound together. Again, you're going to need your periodic table. And the big goal whenever we're making a compound is we want the compound to equal 0. And you might be thinking, well, what the heck does that mean? So I want to refer to us back to our periodic table when we had the opportunity to write down all of those charges for each of the families. So for example, we labeled our periodic table and we said, oh, the alkaline earth metals are the alkaline metals are +1. The alkaline earth metals are +2. Transition metals can be like +3 all the way to +6, and you're really going to have to be told what you're using. We have the fluorine family, or the halogens are -1. Give me a thumbs up if you remember this and you see this on your periodic table. You see these numbers I'm talking about. That's a really important piece to this. Okay, I'm not feeling super good about moving on when only one person gave me a thumbs up that they see these numbers on their periodic table, or that they remember us talking about them. All right, now this makes me feel better. Thank you very much, guys. Okay, so when we say that we want this compound to equal 0, we are really meaning that we want it to equal 0, and we want those numbers that we were talking about, like a +1, a -1, +2s, all of those. When we put those in a compound, we want them to equal 0. If you notice on your periodic table that to the right, or I mean to the left, we have our nonmetals, or I mean our metals. Oh my gosh, I'm screwing everything up. To our left, we have the nonmetals. We have the metals, and they have all a plus charge. We have talked about them wanting to give away their electrons. To the right, we have our nonmetals, and our nonmetals want to take in those electrons, and they have negative numbers. So remember that we're putting a metal and a nonmetal together, and so the idea or the thought is that the metal will give up enough electrons that the nonmetal would then be satisfied, and everything equals out to be 0. So when we do this, we have Na is +1, and we have Cl is -1. And so when we put this compound together, we would say NaCl. And we would do this because for every 1 sodium, we only need 1 chlorine. So 1-to-1 ratio, and you can see like the numbers are the same. So when you can see that you have the numbers the same, we don't write any of the number ones there just by simply saying Na, or by writing down Na, we are saying that we have at least one of these elements or atoms. So we get NaCl. I think this example right here is the most popular example. It's also one that kids tend to understand quite quickly. Not looking down here, but just looking at this one, are there any questions about why that would be NaCl? I need 1 + 1 - 1 equals out to be 0. That's another way to look at it as well. Oop, did not mean to do that. Okay, so now where we get a little bit tricky is when we are going to do something that they have different charges associated with them. So in this case, I have magnesium. Magnesium is a +2. Fluorine is -1. And this is in the wrong spot. So let me, I am just struggling here today. Okay, now, okay, so now we have MgF2, and this is where kids tend to struggle, okay? So because this is a +2, I would need 2 fluorines to make this equal 0. Or you can do what is known as the crisscross method, and that is to take this 2 and put it by the F, and take this 1 and put it by the MG. So this 2 would go by the F, and this 1 would go by the MG. In the crisscross method, you will get everything to equal 0. There's really a couple different ways, and it depends on the way your brain thinks. So if you look at this and you say, okay, to make this equal 0, this compound equals 0, I need to have 2 of these to cancel out the 2 electrons that are waiting here. And this one only needs 1, so I need another fluorine that needs 1 to cancel out these 2. Or you can say, I'm going to crisscross this. I'm going to put the 2 by the F and the 1 by the MG. And remember, we don't necessarily write that number 1 down there. Just writing this here indicates 1. So our formula for this would be MgF2. I'm just going to pause for about 10 seconds and allow that to process in and allow you to see if there's any questions that are immediately there for you before we go on to some practice. Okay. All right, so I'm just going to switch avenues here because I want to have real time show you guys what's going on. All right, so let's get ready to practice, okay? I'm going to put on 2 elements for you. Have them written down here. So calcium is going to mix with chlorine. So that's practice number 1. Practice number 2 is copper plus 2 is going to mix with oxygen. Okay, so I'm going to put 55 seconds on the clock, and I would like for you guys to practice writing the formula, and then we'll come back and do and see what the answers are and see if that leads to any more questions. All right, here we go. So here, this is going to equal CaCl2. If you look on your periodic table, this is a +2 and this is a -1. Now for this one right here, this is copper, and copper, I gave you the copper that we're using. Copper can exist in a couple different ways, and so it was part of that transition metal, so I had to give that to you. Oxygen itself is -2, and so this one ends up being CuO. When you see the answers to this, what questions arise if you were one that did not get correct answers? Okay, I'm not seeing anything come through. There we go. Most of the time, they should be given to you. And for the most part, transition metals will be a +2. 9 times out of 10, a transition metal will be a +2. If it's not given to you, then you can assume a +2. Okay, Tristan. So yeah, I mean, if we visually put this out here, so I'm just gonna so I have Ca, and Ca is part of the +2, okay, which means that this has the 2 electrons that it needs to give away. And Cl is -1, meaning that it only needs 1 electron. So I would need 2 of these so that calcium can give 1 electron here and 1 electron here. And that would give us our CaCl2. You can also go like this. Ca is +2, Cl is -1, and you can crisscross your numbers, meaning this would come and be a subscript down here, and this number would be a subscript down here, and you would then write the CaCl2. There's, just like math, there are a couple different ways that you can figure out the formula. It just is based off of how your brain works. Tristan, that we wrote down a couple of weeks ago. I want to say, I don't even remember, week 5, 6, or 7. We went through and wrote that all down on our periodic table. We went through each family and designated the charge in which it had, and that's why that was super important. All right, let me clear this out here. Hold on. Okay, this is my quick drawing here. So this column right here is +1. This is +2. We'll say that these are +2. This is the transition metals, +2. They can be something different though. And sometimes, if they're not told to you, just say +2. This is +3. And the first one in here is boron. This one right here is +4. And this is carbon. This is nitrogen, and it is -3. So everything down here is +4, -3, +3 down the boron family. And right here we have oxygen, -2. And right here we have fluorine, -1. These are the halogens. And right here is He, and they are 0. Does that help, Tristan? That's it. I'm going to just stop for a second, and I'm going to just pat myself on the back because that is probably the best quick drawing of a periodic table that I've ever done in my entire life and in my entire teaching career. So I'm going to just clap for myself here for a second because it has just been, I've been doing all these little tiny mistakes that are not like me, and that actually just came out awesome. Okay. So, do we feel confident about making an ionic compound, naming it, and do we feel confident writing the formula? Do we want to try one more example of an ionic compound? Okay. I'm going to do one more example, and then we need to talk about the polyatomic ions. So let me just grab another example here. Potassium is going to merge with sulfur. I will put about 40 seconds on the clock. Okay, so here we go. So potassium is going to be +1. Sulfur is, I think, -2. Yeah, sulfur is -2. When I put these together, I'm going to get K2S. So, okay. So remember, I have a 2 here. This needs 2 electrons. This can only give 1. So I'm going to need another one to give the second electron. And that's how we get 2K2S. All right, so we are going to move on. And I want to show you the polyatomic ions, okay? So I'm going to switch back to my presentation here. Okay, so this right here is polyatomic ions. And what polyatomic ions are, they sound super complicated, and they are if we really get into them, but for our purposes, you can consider this like the second periodic table. Everything on here is a compound that does not equal zero. So before we just made our ionic compounds and we were making them add up to zero, these right here are polyatomic ions, or these are compounds that don't equal zero. They are an ion, which means that they have an overall charge. However, they act just like a nonmetal would if they have a negative charge, and they would act like a metal would if they had a positive charge. And you would use them the same exact way. You would use them the exact same way as if they were on the periodic table. The reason this is so important for you to have and to reference is because it gives you the formula, it gives you the name, and it lets you know the charge in which this compound has. Mr. Wozniak and I are really suggesting that you get this in a form that you can refer to when you are working with chemistry. Whether you are going to make a copy on a Google Doc and save it in your drive, whether you handwrite this out in your notebook, or you print this out. Maybe you go to the local library and there's a couple cents for you to print from their library. That's another way you could do it. It is going to save you so much time, and it will save you so much headaches, because if you are looking for something on the periodic table and you cannot find it, 9 times out of 10, that means it's a polyatomic ion. And so you would look at your, as I like to call it, my second periodic table. So at this time, I'm going to go back into my whiteboard so that we can do some examples with these. Okay. If a metal has a Roman numeral like 3 behind it, that means it has a +3 charge. Lead can exist as +3 or +6, I believe. Then you need to look on the periodic table and find out what its charge is. All right, so let me switch back here. Oh, I can't do that. I'm still sharing. All right, so we have this polyatomic ion sheet. I am going to write just a couple of them down so that you can see how we use them, okay? So I'm doing some of the more famous, if you will. So we have a polyatomic called the hydroxide ion. And then we have something called ammonium ion. If you've ever really smelt a really strong urine smell, that's ammonium. And then I'll just pick one of the nitrates. Okay, so here are 3 examples of polyatomic ions. And again, these are just directly off of that sheet. And you might look at them and say, wow, that looks a little bit scary. And don't let it scare you, okay? One thing that we generally do in chemistry, which is really nice. It's not always done, but it's definitely nice when it is done, is 9 times out of 10, a polyatomic ion is going to be with inside of a parenthesis. And when you see that, that is your tip-off that this is a polyatomic ion, and you're going to need to look at that second periodic table. Okay? And again, these are going to work and exist just like they would off of the periodic table. So for example, I'm going to say, I'm going to go like this. I'm going to say sodium is going to join with this hydroxide. Okay. And sodium is +1. This one is -1. So when I join them together, it's going to work just like it would. And I'm just going to put the parentheses in for myself. And I get the formula NaOH. Okay? And then the same is going to work true. So you can see this one is a +1. So this one's going to act just like a metal. So let's say that I want to join this one, which is a +1. And I'm going to join it with oxygen, which is -2. When I do that, again, this is going to work the very same way. I'm going to put my nice little parentheses here. I'm going to put my 2 and then my O. I'm just going to stop and pause here and allow for some processing to happen. And then while that processing is happening, feel free to jump in and put any sort of question you have about using these polyatomic ions. The 2 does not go after the O because the oxygen has a charge of -2, and this compound has a charge of +1. And so I need 2 of these compounds so that each compound can give an electron to oxygen. I just randomly picked oxygen. What else? What would you like the second one to be? I just randomly picked it. I mean, you can put, I mean, we can say NH4, this is plus, and you could say fluorine, which is -1. So in that case, this would be NH4F. You could do it that way. I mean, does it? Do you guys think you are ready to do some of your own? Try one of your own. All right. Did not really want to do that, but okay. Just hate when I forget that. So I'm just going to put this up here again. So here we have OH minus. NH4. Okay. All right, so let's do one where we are going to have lithium and all right, I'm going to put 55 seconds on the clock. See how well you do. All right, let's see how you did. So this one would simply be, this is a +1, this is -1. So we would get this one is -1, so this then would be how do you guys think you did? There you go, Tristan. Any questions when you did this? There you go, Emily. All right, so I do want to respect everyone's time. It is 12:57, so we really only got through ionic compounds, which is fine. Covalent compounds is not very difficult at all. But I just want to make sure that you guys feel confident with the ionic compounds before we go. You may ask some questions, absolutely. At this time, I do want to respect, if you need to go, then absolutely go. If there are some questions that you still have, please ask them now. You too, Tristan, have a great week.